8.3 in Calculus and Vectors is vector, parametric, and now symmetric equations of lines not in 2 space, in 3 space, in R3. So vector and parametric equations that we did in 8.1, 8.2, these are easy, and they're just as easy in R3. The new thing that we're doing here is really symmetric equations. So before we get to symmetric equations, let's figure out why R3 is the same as R squared when we come up with equations for this first example. So we want to determine the vector and parametric equations of the line passing through this 3-dimensional point and this 3-dimensional point. So the process is actually the exact same. Okay, we need a directional vector. We need M. And M in this case is still going to be PQ, and that's going to be 0, -1, 6. Find the vector between P and Q. You got it. And now we can go on to say, well, then R, vector R, must be pick a point. I'm going to pick the first one because it's first, plus some sort of parameter, S, T, whatever. It doesn't really matter. And my directional vector. And I'm done. This is the equation of the line in 3 space. We just add a Z. That's it. So if I want to come up with the parametric equations, that's just as easy. I can say, well, I'll do it here. X equals -2 plus 0s, y equals 3 minus s, and z equals 5 plus 6s. So these are my parametric equations. Now, symmetric equations are a little different. These are derived from solving for each parameter in the parametric equation. So here we have the x, y, and z. These are the parametric equations. But if I solve for the parameter, this s has to be the same as this s, has to be the same as this s. So if we solve all three in terms of s, we can set them all equal to each other because they are all the parameter. So for instance, if I'm using this, I can say, well then, if I solve for s over here, I'm going to get, let me just bring these down actually. X equals -2, y equals 3 minus s, and z equals 5 plus 6s. My parametric equations is just me changing these all into s. Notice how there's no s here, so I can't even use that. I can't solve for s, therefore I don't use it. I'm going to bring over the s and the y, so s equals 3 minus y. Over here, I'm going to leave the s, bring the 5 over, so I'm going to get z minus 5 over 6 is equal to s. And my symmetric equations are just 3 minus y is equal to z minus 5 over 6. If I had an x value, I set it equal to over here, but I don't have one. So these are my symmetric equations for this example. Okay, pretty straightforward. Okay, so there's a formula for symmetric equations. I don't really like following formulas. I like just knowing, what they are, so you can kind of get there from wherever scenario you're in. Formula is a little bit too rigid for me. But this is the formula if maybe it works for you. So if you have your parametric equations here, we have our directional vector A, B, C right there. We know how to do this. We know how to come up with the parametric equations, and we just solve for that parameter S, right? Solve for that parameter S, and we get x minus x naught over A, where A is the x value of the vector, the directional vector. Okay, and we can kind of skip to the symmetric equation from the directional vector and point, which is the vector equation. So let's see how that looks over here. We want to write the symmetric equations of the line passing through these 2 points. So of course, our first step is always going to be, well, we got to find our directional vector. The directional vector between A and B, if I subtract those 2 points, I'm going to get 4, -9, 1. So now I can already come up with the equation of my line. This is -1, 5, 7, plus some sort of parameter of my directional vector. Boom, I have my equation of my vector, or equation of the line in vector form. I can come up with my parametric equations now, but I don't have to. The question is not asking for that. So that could be seen as a waste of time in this case. Is if it's on a test, maybe I'm going to do that to make sure, but I could use this formula from here to come up with my equations. So I'm going to do both. I'm going to show you the parametric equations right here. I'm just going to list them. Takes 2 seconds. I mean, it's not that big of a waste of time, but you know my thoughts on wasting any types of time. X is equal to -1 plus 4t. Y is equal to 5 minus 9t. and z is equal to 7 plus t. So I got to solve all these. So this is what this formula means. Like, take a look at x. I got to move this x naught, this is x naught, right, over. So I'm subtracting x naught. And then I got to divide by the a value of the parameter by 4. That's it. That's all I'm doing. I'm solving. That solves for t. This is t, this is t, this is t. That's it. So my parametric equations, sorry, my symmetric equations, write them in this color, are going to be x plus 1 over 4, right? X plus 1 divided by 4. Y minus 5 divided by negative 9. So let me tell you what that looks like. Y minus 5 divided by negative 9. I never divide by negatives. It's just a bad habit. Don't do it. Just change this to 5 minus y over positive 9. Okay, so this is a little trick that will bring you a long way if you stop dividing by negative numbers. And z is just going to be z minus 7. And these are my symmetric equations that I could have come up with from here, right? I could just do x minus negative 1 divided by 4. Y minus 5 divided by negative 9. Z minus 7 divided by 1. I can come up with them really quickly from vector form, right? Or parametric form, whatever makes you happy. And that's it. 8.3 is pretty simple, just like the rest of math or vectors in general. Don't let symmetric equations slow you down, and definitely don't let 3 space slow you down, because it's the exact same as 2 space.